Adults seem to have these well-established and efficient semantic networks that are fairly consistent across individuals. But ironically, this can come at the cost of memory accuracy, as adults are susceptible to memory distortion. For instance, in the DRM paradigm, when adults hear a list of words semantically related to sleep, they are likely to falsely remember hearing the word sleep itself. Interestingly, children are actually less susceptible to these distortions, and it's thought that this pattern of behavior might point to underlying differences in network structure or content, but it's yet unknown how concept organization differs across development. While we won't be looking at memory distortion in this study, we were interested in why these patterns occur. This led us to the question, how are concepts organized differently in adults and children? Looking at organization, might adults be prone to memory distortion because their networks are efficiently organized, centralizing around important concepts? Or maybe children are just really weird and idiosyncratic. Age differences might also reflect differences in network content. Might these memory differences reflect networks organized around different concepts? Or are adults simply organized more by co-occurrences in the environment? To answer these questions, we developed a free association task by compiling 100 nouns from a pre-existing category norming study and presented participants with 25 word cues each. We ran 100 native English-speaking adults and 100 native English-speaking 4 to 5-year-olds. This was a verbal task where participants were prompted to say the first word they thought of when they heard the cue. To analyze structure, we first created semantic maps to get a sense of global structure. We then analyzed centrality scores to assess how the networks are organized around specific concepts. Finally, we analyzed how idiosyncratic the associates were in each age group to measure consistency within each network. To analyze network content, we looked at centrality scores again, but this time comparing associates shared by both networks or unique to a single network to assess if both networks are heavily shaped by the same concepts. We also looked at co-occurrences in the world in relation to word pair frequency to assess how accurately the networks reflect the environment. We compared this across age groups to assess if adults were more accurately reflecting the environment. And finally, we looked at co-occurrences in shared pairs and those unique to one network to assess whether shared pairs more accurately reflect the environment. With the free association data, we mapped out the semantic networks for adults in red on the left and children in turquoise on the right. Here, the nodes are cues and associates, or responses, and their size signifies associate frequency, so how many times participants responded with that associate. Similarly, the edge width signifies the frequency of that cue to associate pairing. And finally, the dark blue nodes and edges are shared across networks, while the red and turquoise are unique to their respective age group. Given their lower number of thicker edges, you can tell that the adult network is more consistent and organized when compared to the child network, which is quite noisy. And this intuition is confirmed when we look at centrality scores, meaning how the network is organized around specific nodes. High centrality scores reflect nodes that are highly connected and influential, suggesting more consistency and organization in the network. These scores can be broken down into hubs and authorities. Hubs are cues that lead to many associates. On the left, we have hubs from the adult and child networks. With the node size representing hub scores, you can see that children have marginally higher hub scores. This means that children responded to each cue with more variable associates. This explains the noisiness we see above. In comparison, on the right side we have authorities, which are associates that many cues lead to. Here, node size represents authority scores, and you can see that adults have significantly higher authority scores than children. In other words, adult networks are better organized around important concepts. A driving factor behind the above findings seems to be that children present more idiosyncratic associates. With the percentage of idiosyncratic associates on the y-axis, you can see that children produce far more associates that are only produced by a single participant, whereas adults provide fewer, more consistent associates, and thereby have a better organized network. So there are definitely differences in network structure across age groups, but might differences in structure reflect networks that are organized around different concepts? We compared authority scores for associates unique to each network and those common to both networks. With average authority scores on the y-axis, you can see in both the adult figure on the left and the child figure on the right that shared associates have higher authority scores, so are more important within each network. This suggests both networks are organized around the same concepts. We also wanted to know if, beyond child associates simply being more variable, are they actually less reflective of real-world co-occurrence statistics? We used the pre-existing dataset from GLOVE, which calculates word-to-word co-occurrence statistics from a corpora to create co-occurrence scores between words. Using these, we first tried a proof of concept and found on the graph on the left that co-occurrence scores on the y-axis increased with pair frequency on the x-axis. Having found that, we compared co-occurrence scores for pairs found only in the adult network, only in the child network, and shared across networks. On the right, you can see with co-occurrence on the y-axis and the commonality of the pair on the x that adults' pairs had significantly higher co-occurrence scores than children, and that pairs shared by both networks had the highest co-occurrence scores. This suggests that children are not just more variable in their responses, but also less consistent with real-world co-occurrence statistics. To reiterate, we found that the adult network is more centralized and uniform, while the child network is more distributed and idiosyncratic, suggesting better organization in the adult network. We also found that both networks organize around the same concepts, and that adult pairs, frequent pairs, and shared pairs better reflect real-life co-occurrences. As such, adults' better organization and use of real-world co-occurrences provide a possible explanation for the adult susceptibility and child resistance to memory distortion. These findings also show that the beginning of an adult-like network may be present as early as 4 to 5 years, suggesting that the differences in memory may be due more to network structure than content. Finally, I hope to follow up this work by diving into why these network differences occur. In particular, child networks may be shaped by poor generalization and good retention of verbatim information. Thanks for your time.